Hello everyone. How would we get oxygen on Mars? Let's find out. The dream of sending humans to Mars carries with it a fundamental challenge. How do we simply breathe on a world with an atmosphere so drastically different from Earth's? The thin Martian atmosphere is dominated by carbon dioxide, offering no readily available oxygen for humans to survive. Scientists and engineers are tirelessly developing innovative solutions to this problem, exploring ways to obtain this life-giving element and paving the way for a sustainable human presence on the red planet. One of the most promising approaches involves tapping into a resource found abundantly on Mars: water ice. Vast reserves of water ice are locked in the Martian polar ice caps and potentially beneath the surface as permafrost. To obtain oxygen from this source, we'd need to develop the technologies to effectively mine and extract the ice. We would then employ a process called electrolysis, which uses electricity to split water molecules into their constituent elements, hydrogen and oxygen. The oxygen produced this way could be directly used for breathing, stored for later use, or potentially even combined with the hydrogen byproduct to create rocket fuel. Using local resources, a concept known as in situ resource utilization, is considered key to reducing dependence on supplies from Earth and increasing the self-sufficiency of a Mars colony. While extracting ice on a large scale will undoubtedly be complex, another exciting approach offers the potential to pull oxygen directly from Mars' atmosphere. NASA's Perseverance rover carries an experimental instrument designed to demonstrate the feasibility of extracting oxygen from the carbon dioxide-rich Martian air. This instrument, often referred to by its acronym MOXIE, works by employing a process known as solid oxide electrolysis. In essence, MOXIE pulls in carbon dioxide, heats it to extremely high temperatures, and passes it through a system that strips the oxygen from the carbon dioxide molecule, leaving carbon monoxide as a byproduct. While MOXIE currently produces only small quantities of oxygen, it offers a proof of concept that paves the way for larger-scale systems. Future missions might deploy dedicated atmospheric processing units capable of contributing significant amounts of oxygen production on Mars. Furthermore, researchers are exploring ways to potentially manage or even repurpose the carbon monoxide byproduct of this process. For instance, the carbon monoxide could be used in combination with hydrogen to produce methane, a potential fuel source. Beyond targeting existing resources like water ice and atmospheric carbon dioxide, scientists are investigating innovative and even seemingly outlandish approaches that leverage the unique properties of Mars. Some researchers envision using specialized types of photosynthetic bacteria or algae for oxygen production. These organisms, through the process of photosynthesis, naturally absorb carbon dioxide and release oxygen. With careful engineering and genetic modifications to allow them to survive in the harsh Martian environment, bioreactors using these microorganisms could potentially become supplemental oxygen generators on Mars. These bioreactors might even help tackle another vital need by producing food, pharmaceuticals, or biomaterials for the colony. Looking towards the very distant future, the audacious concept of terraforming Mars, gradually altering the planet's environment to make it more hospitable to humans and Earth-based life, also touches upon the quest for oxygen. While terraforming the entirety of Mars into a new Earth is a vision for centuries, if not millennia, into the future, localized or microscale terraforming might be achievable over shorter timescales. Some scientists theorize that by introducing specific types of extremophile microbes or hardy lichens to the Martian soil, we might be able to coax trapped gases out of the ground or break down Martian rocks. These released gases could slowly contribute to thickening the atmosphere and potentially even lead to a slight warming effect over centuries. These processes, combined with the controlled release of potent greenhouse gases, might offer a long-term path towards a more Earth-like atmosphere on Mars, one with a higher oxygen content. It's crucial to recognize that these innovative approaches to oxygen production are likely to be used in combination to support a sustainable human presence on Mars. Initial missions will almost certainly rely heavily on oxygen transported from Earth and supplemented by small-scale oxygen generation experiments. As our foothold on Mars grows, larger ISRU facilities will be needed to extract oxygen from water ice or the Martian atmosphere. Bioreactors might come into play, utilizing biological processes to enhance oxygen generation. Far in the future, the careful introduction of extremophiles could begin the incredibly long process of localized terraforming efforts, potentially creating areas on Mars where the atmosphere is more breathable. The pursuit of answers to Mars' oxygen question is driving innovation in ways that reach far beyond the ambitions of space exploration. Advances in electrolysis systems, life support technologies, resource utilization methods, and bioengineering for harsh environments could find valuable applications here on Earth. From improving methods for water purification or combating pollution to developing more efficient energy storage solutions or closed-loop agricultural systems, the technologies born from the necessity of making Mars habitable promise to improve lives back on our own planet. The challenges of living on Mars are undoubtedly vast and extend far beyond the basic need for oxygen. The harsh radiation environment, ever-present dangers of dust storms, the profound psychological toll of isolation, and the need for reliable food production are factors that will require relentless ingenuity to overcome. Yet, through the pursuit of solutions to these challenges, we unlock extraordinary potential for discovery and push the boundaries of technology in unprecedented ways. By tackling the question of how to obtain oxygen on Mars, we inch ever closer to realizing the dream of becoming an interplanetary species. These bold steps into the cosmos not only expand our horizons but unlock advancements that promise to revolutionize our life here on Earth and reshape our understanding of our place in the universe. Thank you for watching. Please follow for more related videos and see you later. Goodbye.